This is our video for Friday, April 3rd. We have come to our second week, or the end of our second week of online learning. I know it's adjustment for all of us, and we'll keep working through this together. Don't forget about Zoom sessions from 10 to 10:30 every day. I'm available to answer questions and work problems for you. So if you can set your alarm and get up and ask me questions, I'm available. I want to start today on page 504, uh, looking at what we've done this week. We reviewed adding and subtracting rational expressions. We learned how to do partial fraction decomposition, and you had your quiz yesterday. And so today we are going to get back, or we're going to begin talking about matrices. And some of you had matrices last year, and some of you did not. So we're going to kind of start with the basics. And if you're paying any attention, you'll notice that partial fractions was in 7.3, and we are in 7.5. 7.4, they work with matrices and they work with solving systems, and but 7.5 is more kind of the introductory process of matrices and things that you would have done in Algebra 2. So that's where we're going to start. And keep in mind that what we are covering, I'm really working on, thinking about, things that we would have covered in class that are essentials, either if you're going to college algebra or if you're going to AP Cal. And so I'm kind of trying to mix the two together, as I always do. Matrices are something that are in college algebra, or even if you go on to finite math, has a lot of matrices, and we all know it's on the ACT. Which reminds me, somebody emailed me today, which is actually Thursday, and told me that they had gotten their ACT scores back. So if you are a junior and you've gotten your ACT scores, let me know how you did, and we can celebrate together. But most of you will probably still be taking the ACT again at some point, and as we've already talked about, matrices are something that are on there. So we're going to kind of start with an introduction to what a matrix is, and then we will move into adding and subtracting matrices today, and on Monday we'll talk about how to multiply them together. So first of all, just a definition. A matrix is a rectangular array of numbers arranged in rows and columns. So it's a rectangular array of numbers arranged in rows and columns. These matrices are named with capital letters. So if I have matrix A, and it's made up of the numbers 1, 2, 3, 4, 5, 6, and we put big brackets around it. The dimensions of a matrix are very important, as we will see as we go through the process of adding and subtracting and multiplying. The dimensions are always the number of rows by the number of columns. And we do use the old X symbol for writing these together. Remember that rows go across and columns go up and down. So this matrix A is a 2 by 3 matrix. Think about like a 2 by 4 piece of lumber. This has 2 rows and 3 columns. Each individual number in a matrix is called an element. So an element is a number in a matrix. And the way that they will identify a particular number is this is capital A matrix. If they want a number within that matrix, they'll use a lowercase a, and that little letter will have 2 numbers with it. And so this is read element 2, 1. There's kind of a pause between it. It's not 21, it's element 2, 1. The first number, the number 2, tells you what row to look at. The second number tells you what column you're looking at. So if we want element A21, that means they want the number that's in matrix A that is in the second row, first column. So that would be the number 4. So element A21 is the number 4. If they had A13, then they're saying they want the number that's in the first row, third column, and that would be the number 3. Now, if you go ahead and turn in your book to page 514, and let's look at number Okay, correction there. Don't turn to page 514 yet. Stay on page 504. And in the sentence below the blue box, it says 2 matrices are equal if they have the same order and all of their corresponding entries are equal. So we need to talk about a couple of things there. First of all, in Algebra 2, it talks about the dimensions of a matrix, so rows by columns, 2 by 3. In the pre-cal book, when they want dimensions, they refer to it as order. And so the order of this matrix would be a 2 by 3. So I don't know why the vocabulary changes a little bit, but dimensions and order are referring to the same thing. Okay, the second thing I want to talk about is equal matrices. And it says equal matrices have the same order, so that means that they're going to be the same size, and their corresponding elements are equal. So now I want you to turn to page 514, and we'll see what that means by their corresponding elements are equal. So if we go to 514, and we look at number 1, we have the matrix X, negative 2, 7y on the left side, and we have negative 4, negative 2, 7, and 22 on the right side. And the directions say find X, Y, and Z. So right here, it's telling us that these two matrices are equal. And by definition, if they're equal, then that means that corresponding elements, that means numbers that are in the same location in each matrix are equal. So you can see that negative 2 and negative 2 are equal, and 7 is 7. Therefore, X would have to be negative 4, and Y would have to be 22. It's kind of common sense. If they're in equal matrices and they're in the same location in each matrix, then they have to be equal to each other. So if you look at number 3, we have 3 by 4 matrices, and on the left side we have all the numbers. On the right side we are missing a few numbers, and so if you line up the corresponding elements, you'll see that 5 is equal to 2x plus 7, that 12 is equal to 3y, and that 3z minus 14 is equal to 4. And then you could solve each one of those equations for y, for the variable. And so you can see that y is equal to 4. We are going to have to add 14 over, and we're going to end up with 28 over 3 for z. And here we're going to subtract and end up with x equals negative 1. So just equal matrices mean that your corresponding elements are equal. Now, if we look at the section 5 through 12, it says find if possible a plus b, a minus b, 3 times a, and 3a minus 2b. So let's start with number 7. And matrix A is 8, -1, 2, 3, -4, and 5. And matrix B, 1, 6, -1, -5, 1, and 10. Now the first thing you need to know, to be able to add and subtract matrices, they have to have the same dimensions. So they have to be the same size. So matrix A, we've got 1, 2, 3 rows and 2 columns. So this is a 3 by 2. Matrix B is also a 3 by 2, so we would be able to add them together or to subtract them. And to add or subtract, you just add or subtract the corresponding elements. So if we wanted to add these two matrices together, you take the number that's in the first row, first column, and you add it to the number in matrix B, first row, first column. So I'm just going to put a plus sign right here. And 8 plus 1 is 9. -1 plus 6 is 5. 2 plus -1 is 1. 3 plus -5 is -2. -4 plus 1 is -3. And 5 plus 10 is 15. So when we add them together, we'll get 9, 5, 1, -2, -3, and 15. Just be careful with your negatives. Now, if we want to subtract the two matrices, again, they are the same size. So we can do that. So I'm going to go up here and mark this out just so I don't have to rewrite it all. And this time we're going to subtract. So 8 minus 1 is 7. -1 minus 6 is -7. 2 minus -1 is 3. 3 minus -5 is 8. -4 minus 1 is -5. 5 minus 10 is -5. So 7, -7, 3, 8, -5, and -5. Now this was A, this was B. For part C, they want us to find 3 times A. When you have a number in front, that's called a scalar. And if I were in class, if we were in class, I would say, what do you think we do with the 3? And I hope you would say distribute. And that's really all it is. A scalar is just a number that they want you to multiply through your matrix. So I'm going to multiply everything in matrix A by 3. And so 3 times 8 is 24. 3 times -1 is -3. 2 times 3 is 6. 3 times 3 is 9. -4 times 3 is -12. And 5 times 3 is 15. So 3a would be 24, -3, 6, 9, -12, and 15. Now for part D, they want us to take 3a and subtract 2b. So I know that I just found 3a is 24, -3, 6, 9, -12, and 15. And I want to subtract. Now here, I'm going to leave the subtraction and just distribute the 2. If you distribute -2, you would put a plus sign here. Don't do double negatives, because then you go in a circle. So I'm just bringing down the subtraction, and then I'm going to take 2 and multiply it by everything in matrix B. So I'm going to have 2, 12, -2, -10, 2, and 20. So 2, 12, negative 2, negative 10, 2, and 20. Now I just want to subtract our answers here. And so 24 minus 2 is 22. Negative 3 minus 12 is negative 15. 6 minus negative 2 is 8. 9 minus negative 10 is 19. Negative 12 minus 2 is negative 14. 15 minus 20 is negative 5. So 3a minus 2b is 22, negative 15, 8, 19, negative 14, negative 15. So today we've talked about just what a matrix is. It's just a rectangular array of numbers in rows and columns. We've talked about equal matrices and how equal matrices have corresponding values or corresponding elements that are equal. And then to add and subtract, they need to be the same size. And then you basically just add and subtract. Now, if you are asked to add or subtract matrices that are not the same size, just write "not possible" is all that you need to do. All right. Your work for today is on page 514, and I want you to do the even 2 through 8, number 12, number 16, 24, and 26. Tomorrow we'll talk about how to multiply the matrices together.